How do elastic and plastic strain differ? Imagine bending a paperclip. At first, it bends easily and springs back when you let go. But if you keep bending it, it eventually stays deformed. That's a perfect example of how materials stretch and change shape under stress. Today, we're going to explore the difference between elastic and plastic strain, two ways materials respond when forces act upon them. Elastic strain is like stretching a rubber band. When you pull on it, it elongates, but once you stop, it snaps back to its original shape. This happens because the atomic bonds inside the material stretch but do not break or slip past each other. The amount of elastic strain is directly proportional to the stress applied, following a rule called Hooke's law. This means if you double the force, the stretch doubles too, as long as you stay within the elastic limit. Elastic deformation is temporary and harmless because the material recovers fully once the load is removed. Plastic strain is quite different. Think about bending a paperclip past its elastic limit. It stays bent even after you stop applying force. This is because the atomic bonds have broken and moved past each other, creating permanent change. This process involves dislocations, which are defects inside the crystal structure of metals and other materials. When the stress exceeds the elastic limit, these dislocations move along specific planes, causing the material to deform permanently. Plastic deformation accumulates with continued stress and can make the material stronger but less flexible. If the stress keeps increasing, the material can eventually crack or break. To sum it up, elastic strain is reversible. The material returns to its original shape after the stress is gone. Plastic strain is permanent. The shape stays changed even after the load is removed. In real-world applications, elastic deformation is safe because it doesn't damage the material's structure. But when plastic deformation happens, it can weaken the material and lead to cracks or failure over time. Recognizing when a material transitions from elastic to plastic deformation helps engineers design safer, more reliable products. Mathematically, elastic strain can be calculated by dividing the applied stress by the elastic modulus, which measures stiffness. Plastic strain is the total strain minus the elastic strain, showing how much permanent deformation has occurred. Knowing these differences helps in predicting when a material might fail and in designing components that resist permanent damage under normal use.